Hello everyone, welcome to my spectral analysis breakdown for compound C6H12O2 for the signed problem number 1. In this video, I'll walk you through how I interpreted the IR, the 13C NMR, and the 1H NMR spectra to propose a complete structure. I will also show you how I calculated the degrees of unsaturation and filled out the data tables and pieced everything together. Let's get started. So, as I told you, the molecular formula is C6H12O2, and to figure out the actual structure, the first thing that I had to do was to calculate the degree of unsaturation, or as it's called, du, which tells us how many double bonds, rings, or even pi systems are in a molecule. This is the formula I used. 2 times the carbon plus 2 minus the number of hydrogen atoms there are, all divided by 2. So given that our formula is C6H12O2, our carbon in this over here will be replaced by 6, and the H will be replaced by 12. So this is what will happen, and after we do the algebra, we get 1. This means that the molecule has 1 double bond or ring. Now this will be important later. Next, I looked at the IR spectrum, and by looking at it, we can see that there's a strong sharp peak around 1735 centimeters, which kind of shows the carbonyl group, specifically probably of an ester or a carboxylic acid. There's also a peak around 2980, which can show us the CH stretch, and then there's a lot of broad set of peaks over here from around probably from 1100 to 1300, and this shows a CO stretch, which again might be showing an ester. So another thing that I noted was that there was no alcohol peak around, it's usually seen over here, but as you can see there's none over here, so that means it's not a alcohol or a carboxylic acid, which also has an OH peak, and this all helps me decide that this is an ester that we're dealing with. Now we go to the 13C NMR spectrum analysis, where there are 5 total peaks. So we have this 2, 3, 4, and 5. And the first one that we're looking at is at 175 ppm, and it's clearly a carbonyl atom for an ester. Then there's another one at 60, which is an indicative of a CH2 group that is probably attached to an oxygen. Then for 40, 25, and 10, they all look like alkyl carbons almost. And then this helps us understand that this is a carbonyl oxygen bound carbon. And then we went to the next one, the NMR spectrum analysis, and over here we just saw all of these, and we saw that there's a quartet and a triplet combo at about 4.1, and then again at 1.2, which is like a classic ethyl group that is bonded to an oxygen, so we know that it's an ethyl ester. The rest of the protons suggest that we have a straight chain of butyl group that is on one side of the ester. So now we piece it all together, and I used all the things that I've explained to you guys and put them all in here in the table. And now we know that it's supposed to be an ester functional group, as we saw from the IR and the NMR, and then the carbon framework supports an ethyl group, and the other side should have a butyl group that ends in like a normal CH3. If we put all of this together with like one butyl group on one side and an ethyl group on one side, we should get ethyl butanoate, which or like it's also known as think butyric acid ethyl ester. I'm not sure, but I think so. And this is what I came up with the structure to be looking like. And so here the molecule has 1, 2, 3, 4, 5, 6 carbons, and then we have 12 hydrogens, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we should also have 2 oxygens, so 1 and 2. It has 1 degree of unsaturation, which then all match the formula that we are supposed to have for C6H12O2. I hope this video was helpful. The unknown compound now we know is ethyl butanoate, which was confirmed. We're using IR, NMR, and hydrogen NMR. Thanks for watching, and I hope all of these things come together to answer anything, like any questions, or if you have any questions, like put it in the comments. Thank you. Have a great day.